Joining him on stage, someone with over 8 years of industry experience. He's a member of the WSO2's architecture team that drives development and enhancement of overall WSO2 platform capabilities. He's also one of the lead architects behind the WSO2 Carbon and WSO2 Update Manager projects. Ladies and gentlemen, please welcome Founder, Chief Executive Officer and Chief Architect WSO2, Dr. Sanjiva Weerawarana, along with Director Platform Architecture WSO2, Mr. Sameera Jayasoma. It's all about Ballerina.
Good evening. Thank you very much for giving me the opportunity to talk to everybody. I'm here to talk to you a little bit about this thing called Ballerina that we're working on. And the objective is to give you a little bit of an understanding of what this is about, how it works, and what we're trying to do with it. And it's a two-part presentation, so I'm going to talk about the first part, and then Sameera will come and talk about the second part of it. OK, I'm going to see whether this clicking works. So what is Ballerina? Ballerina is a brand new programming language that we are in the process of creating. We've been working on this we've been actively working on exactly this particular concept for about a year, but we've been working on the things behind it for a very long time. And it's quite different from pretty much any programming language you have used ever. So let me try to explain what we're trying to achieve, what the objectives are, and how we expect to kind of get it to usability level. So let me just go through a few high-level points about what it is. It's a parallel programming language that has been optimized for certain kind of scenarios. It's not meant to be a general-purpose language, but it's for a very specific, for specific kinds of scenarios. It's extremely powerful for that. It's also unusual in having both a textual representation as well as a complete graphic representation. So you can actually program Ballerina totally graphically if you want, or textually. And they have exactly the same semantics. They are a canonical graphical representation. It is not a picture drawing tool. It's a way to write the program in a graphic form completely. It's also strongly typed and statically typed, and it's a very powerful type system that tries to unify a whole lot of stuff that people deal with every day. And we'll get into a little bit more detail about that as we go along. It's very carefully designed to work with the network. That is really the primary objective of this programming language, to be a language that works very closely and very naturally with network-oriented data, network services, network APIs, and so forth, and different data formats, things like that. Right? And also radically internationalized. I'll show you what that means in a second. So let me get going here. So if you look at any program, you have to say hello world. So this is a hello world program, so it doesn't look any different from any other hello world you've seen typically, right? So it just says hello world. And this is in English. Now let me show hello world in Sinhalese, right? So there's some font issues here. The Unicode text is not showing through correctly. Now, if you use Java, if you use Go, if you use many languages, they support Unicode. You can print any Unicode sequence in any of those languages. But what we're trying to do with Ballerina is actually go a lot further with it. If you notice, even the keywords are changed to Sinhalese, right? And the next one is hello world in Tamil, right? And the objective is to really get to a point where if you are learning how to program a computer, why is English a prerequisite to learn how to program a computer? And this is not a joke. You can't read this, I'm sure, from the back. But this is a sort of a so when we are done with this, there won't be a single word of English in here. Right? And the objective is to make it so that you can have language packs for different languages. So if somebody wants to convert it into Thai, you can write the things into language and get on with it. And there are some grammar differences. So that is, for example, in Sinhalese, the way you say, in English, you say, if condition, then do this. In Sinhalese, it's the other way around. It's a condition, if, then do that. Right? So there has to be some grammar changes in order to make it really work as a natural form in another language. So it's designed to support that. This is still experimental stuff. This is not in the code base we are releasing right now. But this is something we want to keep working on. And that's what I meant by radical internationalization. Not just we can print foreign characters, right? Unicode characters. Anybody can do that now. In fact, we didn't have to do anything to make Unicode work. It just works in any modern language system now. OK. So this is another version of Hello World. This is a bit different. This is trying to illustrate a key aspect of Ballerina about how Ballerina works. So Ballerina is designed around this concept of sequence diagrams. I think if you're a programmer, you've run into sequence diagrams, right? Sequence diagrams are ways of saying, here are multiple different people doing different things, and each one is a sequential line of work, and you can have many of those in parallel, and then there's ways of interacting between them. So in Ballerina, this is a very boring sequence diagram. Here there are 3 parallel workers, and each one is going to just say hello world. And what's interesting is in Ballerina, the concept of parallelism is a built-in natural concept. So here it just says, when that function is called, start all 3 workers all together, and they'll run. Now, this is a dead boring example, right? There's no communication between them and so forth. But what you have, you can't see the text, but on the top, there are some arguments that come to the function. They're all available to all the workers, all the different the lifelines that are in the sequence diagram. And of course, you can run it. So when you run it, you run like that. So there's a Ballerina command. You say Ballerina run main, hello world.bal, and that was the first one, and the second one. And the second one, because it's running in parallel, every time you run it, you get different ordered output. Okay, because it's completely parallel. There's no coordination. There's no synchronization. So whoever gets an execution thread first runs. Right? When you eventually print into a console is sequential. So it has to get a lock on that and write to that, and so that orders the events. All right. Okay, so this is another example in Ballerina. This is creating a service. It's a remotely accessible service that does the same thing. It just says hello world. And it's also binding that service to HTTP. So these are concepts of Ballerina that I'm going to talk a little bit about. So here it just says there's a resource called say hello. And when that gets invoked, it's going to create a string response and send it back, right? So this is what it looks like. This is the composer for Ballerina that we have written. We'll talk more about this stuff later. And it just looks like, again, a sequence diagram. And to run the service, you just run the service. You just say run this service, and then you can use curl or whatever mechanism to hit the service and see whether it works. All right, so it works. OK, so let me spend a little bit of time talking about the key concepts of Ballerina so you kind of understand what the thinking behind Ballerina is. All right? So the first is this idea of services and resources. So let me use a picture to explain that. In networked interactions, the normal model of interaction is that you have an endpoint, and then you have a set of things you can do with that endpoint, some URL, some host port, or some protocol. That's what a service is. It's a collection of things that you can do at one endpoint. And each thing you can do there is a resource. So it's a very RESTful kind of terminology in HTTP, but it's not HTTP specific at all. It's just a fundamental concept about network endpoints and how you can program them. And each network endpoint is just a sequence diagram. Now you have to think about and see how do you convert a sequence diagram into a function, because this is basically a function. So the way you convert a sequence diagram into a function is you block the time at which it starts and the time at which it finishes. And that, whatever execution that happens is the point at which you come in, that stuff happens, and then you leave. Right? That's basically what Ballerina does. So there's syntax for doing that, and then there's the approach of doing it here. Then if you notice the lines here that says worker, those are the parallel threads of execution that you program. Then there's another concept called connectors and actions. Connectors are things that represent external endpoints. So when you write a program these days, pretty much anything you do, for example, if you use all the Google services, they're APIs. So every Google service that you interact with a remote system, that you have some representation in your program and you send it a message, it does its thing, you get a response back. So here in the Ballerina model, a connector represents a remote service. So it's like a stub conceptually, right? And then the actions are how you interact with them. So those are blocking interactions where if you have this line, that's a synchronization point. Right? So you have parallel execution, and at some point you say, I want to call that remote thing, it does something, and then gets a result back and keep going. Now, we have generalized this concept of connector to a very broad level. So a connector can be something as a web service, a OAuth protected HTTP endpoint. It can be a JMS endpoint. It can be a database. It can be a file. It can be lots of different things. And then when you have sorry, let me go back and tell you about that. So those are the connectors and actions. And we also have functions. I'm not really going to talk about functions. Functions are just functions, right? Like the hello world example was the main function running. It just has a bunch of workers, and they run, and when they finish, the function returns. When you write a service in Ballerina, the services are attached to some kind of network access. So you write logic, you say, I want this behavior to be available over the network. And that's what this server connector stuff is. So we have ways of connecting to any kind of network protocol. So you can write it to a TCP protocol. You can say, I want to receive JMS messages. I want to receive MQTT messages. I want to receive WebSocket interactions, and so forth. All of these are supported in the language. So I talked a little bit about connectors. I'm going to keep going in the interest of time. And so again, the connector scenario was when you have an action is the one that interacts with the connector, and it's represented like that, right? So we model everything you do in a program into a sequence diagram. And this is an important driving principle behind the design of Ballerina. So developers have used sequence diagrams to explain what programs do for a very long time. Right? If you have a complicated parallel scenario and you're trying to explain to somebody saying what's happening, who does what, and who waits for what, and so forth, you draw a sequence diagram. In Ballerina, that sequence diagram is the program you write, is the program you run. Right? So that's the interesting aspect of it. So let me spend a little bit of time talking about what makes Ballerina interesting. It has a whole bunch of characteristics which are kind of different from most languages, and that's kind of what makes Ballerina interesting. So I'm going to spend a bit of time talking about those, and then I'll give it over to Sameera to talk about some other things. So the first thing is that Ballerina knows this concept of a main program and a service. So let me explain that. So if you learn how to use Java, in Java there's only one thing. There's a thing called a Java class, and you have any kind of methods, and main is another method you can put into a class. And the concept of network service is layered on. In the case of Java, if you use Tomcat, for example, Tomcat is what brings the network service concept. And there's a spec called the servlet spec, et cetera, JAX-RS, JAX-WS, that tell you how to convert a program into a network accessible endpoint. The language itself doesn't know it's networked. The problem with that is when you do that, the language doesn't know that when some calls come in, they're not as safe as an in-memory call. Okay? It doesn't have that information. So in Ballerina, we have made it a point to say you have two kinds of things you can run. One is a normal main. You run the program. When you run the program, that entry point gets called, and whatever there runs. The second one is you have a network endpoint. And it knows that these are both are natural things and both are part of the overall architecture of things that you write today when you write programs. The second one is Ballerina knows JSON, XML, and SQL. This is a very important thing. So every program you write, if you write anything for the web, you end up doing something with the database. You often end up doing something with either JSON or XML, or often both. And you often have to merge all these things together. And there's a lot of technology created for that. There's all these ORM systems for moving SQL data into object-oriented models. And then there are data binding architectures for moving from JSON to Java or JSON to whatever thing, et cetera, et cetera. In Ballerina, you don't need any of that because it inherently understands the data schema architecture for XML, for JSON, and relational tabular data. Right? This has been designed from. This is probably the most important part of Ballerina in terms of how it will help people write more productively, write code more productively. Because all that pain of dealing with mismatched type systems, SQL type system doesn't match with Java or C# or PHP or whatever language you're programming, or Python or anything. And then neither does it match with JSON and so forth. Here we have taken a lot of pain to try to create a single data model that works across all of these things, so that you have a single architecture that works across everything. Also, we have done a lot of work to make it transactional. So if you're doing data interactions, you can't do database stuff without transactions. So this has a full transaction model built into the language as well. And there's a way to transform data too. Because a very common problem in things when you write things with the other people's services, you might take something from a Google API, and maybe you call a Facebook API, maybe use some other API. When you do that, you have to move data back and forth from this format to that format and so forth. So Ballerina recognizes that that is a very common, everyday thing to do and has language constructs for doing that in a clean, simple way. It also knows network protocols. I briefly mentioned this earlier. It knows the understanding of various server protocols, various client protocols, has APIs for all kinds of things and so forth. So this is a highly extensible model, of course. You can generate additional ones or write additional ones. Ballerina also knows Swagger. So Ballerina's way of implementing a service, when you look at the interface of the service written in Ballerina, that interface is actually a Swagger representation if the interface is bound to HTTP. So there is no difference in editing a program in Ballerina or editing the program in Swagger if you're using Swagger. Right? It sort of eliminates this challenge of interface first design typically, which is that you can write the interface once, generate code, and if you need to change the interface, you're up a creek. This way, you're not. You can keep changing it. I mentioned the parallelism aspect already. It is absolutely designed to be parallel because sequence diagrams don't understand the concept of sequential programming. They only understand the concept of parallel programming. Right? And all of us, well, I don't know about all of you guys, but certainly when I learned how to program, and every language, all the way through Java to Go, starts with a sequential program and then says, well, there's ways of running something in parallel. Ballerina is different. Ballerina says everything is parallel. There's no sequential programs. You just have any number of things and you run them. That's it. Because it's got a whole lot of network awareness built in, we can also do a bunch of safety stuff. So we're working on this right now. There's this concept called tainting, which is tracking the data that comes over the network and being able to record what's going on with that so that if you try to insert something into a SQL database, for example, with data that came over the network, the language compiler can statically tell you that that is not safe. And you can't do that. As you know, there's all kinds of network attacks that happen. So the more help you can get to write safe code, the better it is. And that's something that we are working very heavily on. Sorry, I mixed up a slide here. This is talking about Docker. So we also have a bunch of support for Docker. Okay, titles and the content are mixed up. Sorry about that. So taint tracking of delivered data, and then also built-in concepts are like retrying. So if you use web applications, it's very, very common that sometimes you make a network call and it just fails temporarily. So when it fails temporarily, applications break. And that's kind of silly because often you just retry and it works. It's just some network glitch that happened in that one instant. So that kind of concept is going to be built into Ballerina. So you just say, I need to make a connection to that. And if it fails once, it'll reconnect and keep going. And you won't even have to deal with it. So I talked a little bit about Docker, so I won't spend much time now. And of course, everything is open source. So WSUD is creating this language. We are the ones who've been working on this. But all the source code is under Apache license. There's a GitHub project. And anybody is welcome to participate and contribute and so forth. And it's something that we want to keep developing and make it something that is really an open language, not something that is controlled by WSO2. But we also plan to obviously make products with it and embed it into the WSO2 products. And I'm not going to talk about that stuff right now. All right, one more slide. I'm going to give it up to Sameera. Ballerina is more than just a language. So when you program today, it's not just a language compiler or a language runtime that you need. You also need IDE tools. You need testing tools. You need documentation tools. You need ways of managing code so you can share code with other people. And we have built all of that for Ballerina. So this is not just a language. It's an entire language system you're building. So things like Maven or NPM, those kind of concepts are built into Ballerina in order to make it work practically in today's world. All right. I'm going to step back and let Sameera take over. He's going to go through some examples so you kind of see what Ballerina is, and then also talk a little bit about what we're going to do next with Ballerina. Thank you.
Hello, everyone. So I think Sanjiva, gave you a nice introduction to Ballerina. He basically explained why we have basically developed a language called Ballerina and what's unique about Ballerina, and also what factors make Ballerina unique. So can I get the slides? Yeah, thank you. So yeah, so I think it's time for us to go through basically concrete samples, concrete code that we have written in Ballerina. So he explained the concepts, the basic concepts and the features of Ballerina. So we can go through the few samples. So the first sample, it's a command line application that we have written in Ballerina. Right? So any guesses? Like what this program does? Yeah. So it's a command line application. So you just run it in the command line. And as usual, it has a main function, right? So at the beginning, you can see we have imported certain packages. And up there, you can see some packages starting with ballerina dot. So those are the built-in packages. And there's the last one, some community contributed packages. Obviously, so the last one is developed by Ballerina. So this program, what it does is, it's basically access your Twitter account and basically read a bunch of tweets and then just print information. This is just to show you some features in Ballerina. Yeah, so it's a main function, and we basically extract certain arguments from the command line as command line arguments, and then we create the Twitter connector. So Sanjiva explained what a connector is. A connector is basically an way to interact with network APIs. So here, Twitter is exposing an API. So we have created our own connector so that you can, it gives you a very easy to use API. And it's like a stub. So here you can see, we create a connector by giving all these access credentials and other necessary data, and then call that search API, Twitter connector.search. There we basically give a search query and get data, right? Then you get the response message. So I think Sanjiv explained, so there are types in Ballerina, like JSON, message, XML. So those are built-in types in Ballerina. So here, the Twitter connector gives you a message. And that message contains the payload, headers, all these things that you want to deal with. Then what you do, you call the messages.getJSON, and you pass the message. Now what you get out of that function is a JSON that you got from Twitter, right? So you can say JSON tweets, and then you do some error checking. And then the last, you can see tweets, and then you check the status, so you get an array. So if you can see here, so this JSON object, you can navigate the JSON object just like, and like in Java, you basically say foo.a.b. like that. So you can navigate that JSON object like that. And you can see tweets.status. So status is an array. So you give the index, you get the 0th index, and then you basically print some properties. So this is a very basic program that we have written in Ballerina, which happens to be a command line application. Right. So the next one is a bit interesting because here we create a service. And any guesses? Yeah. So here, in the previous example, we basically consume a service. In this example, we basically produce a service. And that service is backed by a database. So here we are basically exposing data via Ballerina. So if I go through certain aspects of this program, you can see the service keyword, and that is the start of your service. And then you have two resources. First resource is the get resource, where you can invoke using a get action. And the next one, which is collapse, is a post resource. Basically, you can access by doing a post request. So in the get resource, we basically talk to the SQL connector. This SQL connector allows you to basically connect to a database and execute queries. So here we execute a select query, and that is a select query. And then as an output, you get a data table. Data table is a tabular data structure. And you can basically, it's a cursor-based data structure, like the result set in Ballerina, in Java. And then you can convert the data table into JSON. You directly convert your SQL response, SQL result set into a JSON. And then you can directly send that JSON as the payload. You respond with JSON messages. The next one is the same thing, but now you are looking at a post resource. The more interesting part of this resource is a transaction bit. So now you can see like in Ballerina, the transaction capability, as Sanjiva explained, is built in. So you can't do this in Java. Then you have to use transaction libraries, JavaX transaction. But in Ballerina, the transaction behavior is built in. So inside the transaction, you basically do some two insert queries, right? And if the transaction is aborted, the aborted block will be invoked, and you can do some cleanup if you want. So that is the idea. And at the end, basically, you send a string payload saying that your transaction is succeeded. Right. Yeah. So I'll basically explain like what Ballerina, some concrete code that we have written using Ballerina. So let's talk about the future of Ballerina. So Ballerina is still, we are developing Ballerina. It's not done. We are introducing many features. You can always like keep an eye on us and see what we are doing. So it's, at the moment, we are introducing rapid changes to Ballerina. So you might be wondering like why Ballerina is unique and why we have developed a language like Ballerina. Why can't we use Java? Why can't we use PHP? Why can't we use Go? Like, there are many other languages. The reason is we want to give like people like high-level language so that you can program with network-friendly APIs, network-friendly programs. It's like if you are developing some integration services or micro-integrations, where most of the time what you do is integrate a bunch of network APIs. You get some data from some API, and then you pass the data to another API, and then you do some mediation, and you filter, you transform data between XML and JSON. If you happen to write some scenario, some code, then Ballerina is the best solution. Because you don't need to deal with, like if you write, for example, if I go back, yeah, if you write this program in Java, how many lines of code you have to write? Just think about that. And even the transactions bit. Here we simply create a SQL connector, and we do inserts, that's all. And all the other aspects like security, the resiliency aspect that Sanjiva talked about, we handle that internally. But in Java, you have to always deal with SQL injection, all the stuff. So that's what makes Ballerina unique. Yeah. And if you're just developing some boring code like doing mathematical calculations, do some other stuff, not really, nothing about APIs, web APIs, then Ballerina is not the solution. You can always go with other languages. Yeah. And then what's next? So we have just released Ballerina. The latest version of Ballerina is up there in our site. You can basically download and follow the instructions to install and try out some samples and give us feedback. There are various channels you can contact. But the Ballerina is in, the complete work is still in progress. So we're introducing so many features. We are changing certain things here and there. So from this version to next version, your programs might break because we have changed syntax. Because it's under rapid development. And because we are changing stuff, maybe documents are not up to date. There can be a few bugs here and there. That's like a normal fact in software. And also, we are doing this Ballerina hackathon. I think it's early July. So I think it's a good opportunity for you all. Just come and join us to solve some interesting problems using Ballerina. So you can think of like, if you consider the 80-20 rule, you can think of some problems that you can solve in Ballerina. And just you can, maybe there will be some way, so that you can send your proposals, just come up with ideas, and then you can join with us to solve interesting problems in Ballerina. Right. All right. Thank you all. So it's time to make integration great again. I'm sure you have heard of this. So thank you. And thank you, Dialog, for giving us this opportunity.